Back to TBS Skylabs. So, for my class, at least, this is going to be the most important topic for our middle school test at the end. But also, I think for everybody, it's like the most important thing to understand, and that's because this is what makes the world, or computers, if you like, at least, work. So, how does your television work? How does your smartphone work? It works using these magical devices called transistors. Now, transistors, although they are possibly the most important thing ever made, they are effectively just a little switch. Now, we looked at switches before. So when something happens, it allows the power to flow. And when something doesn't happen, it doesn't allow the power to flow. And it's very similar for a transistor. Now, transistors come in different shapes and sizes. These ones are the ones that we're going to be looking at. These are reasonably low current transistors. You can get bigger transistors. I'm not even sure if this is a transistor, but I just wanted to show you that you can get bigger ones, which operate more or less in the same principle, but which are can deal with much bigger currents and stuff like this. On the other side of things, we can combine transistors together to make CPUs. So that's like, you know, the stuff you buy from Intel or whatever. And that can basically allow your computer to think. But halfway in between, we also have these integrated circuits, which are kind of maybe more similar to these guys. They're like a combination of these to have a certain function. And then the extension on that is making like a CPU that can do all if you're thinking and play Fortnite or Assassin's Creed or whatever you're into. I have no idea what the current game is. I just play EU4 all day. Okay, so I'm going to put these ones to the side for now because we don't actually need those. Here is one whose legs I have bent earlier. Now, you're going to have trouble fitting that directly onto your board, so it's good if you make like a kind of weird, how would you describe it? Like a pitchfork kind of shape, so that it's going to fit onto your board nice and easy. Again, with electronic stuff, you're going to have to bend stuff and move stuff around. As much as possible, try not overbend it or think legs are going to snap off. But just think of that as our little switch. Now, apologies, I only have a red pen. So, it is what it is. So, anywho. So this thing here, my transistor, has 3 different legs. Now, the legs have different names. If I think I'm right, we have collector, base, and emitter. I may well be wrong, so please feel free to shout at me in the comments. I just kind of remember what they do. Because again, we're really focusing on the practical side here, rather than the theory as much as we can. Now, what I'm going to do is I'm going to post a video as to how these work. Some Irish guy made that's really, really good, and sort of gives you some experience of how this all fits together. But we just want to get it working. So, anyway, that left leg is going to connect to my positive, and in our case it's going to be 5 volts. Now again, if I used a bigger voltage, I might be using a special kind of transistor instead, but for simple electronics we can use these here. Now there's lots of different types, lots of different ratings, but they all more or less work the same way. Now, on the other side of our transistor, I'm going to have the emitter, so it's going to output the electricity, or output the current. Yep. And then that's going to connect into a system which is almost identical to what we had before. So here I'm going to have my... I can never get these to sit the way I want. I always just roll around, but hopefully, maybe if I bend it a wee bit, it will stay still. It's going to stay still the wrong way because I bent the wrong leg. So, okay. Give up. But, stop rolling LED. Stay where you were told. Okay, but basically, I am going to have the long leg of the LED connected to the emitter, or the positive side of the electricity. Now that, if it doesn't roll around, okay, I hope you get the point. But positive leg on one side, other leg on the other. And again, we want to protect that using a... doesn't help it's windy up here. Using a resistor. Okay, so then I've got my resistor, and again it's just using 220 ohms. I'm sure I've got one here. Maybe, maybe not. But again, I'm just going to connect in a resistor. Let me just put one off here just so you can see what's going on. Onto here. And so then, once we've got that, it's going to connect to the negative or the ground of our system. So we're going to flow through the 5 volts, or sorry, from the 5 volts into the one leg of the LED, the left leg. Notice this is the flat side that's on the front. Sorry, in case you can't see that, it's the flat side. Now, at the moment, this transistor will stop the electricity from flowing. It's just the same as my button, as if I have not pressed it yet. However, later, the emitter should output the electricity into my LED, the big leg. Give up. Okay, but into the LED, and then the other side should hopefully, oh my god, okay, should hopefully come out into the resistor, which is going to be reducing the current to protect our LED, which in turn is going to flow out to the negative. Alright, now how do we actually turn on our transistor? Well, to do that, we need to apply some additional current to the, again, I might be wrong on names here, but to the base of the transistor. Now, one important point to think about here is that what is going into the base of the transistor is normally going to be significantly less than is here. It only needs a really small current to be able to activate our transistor. Okay, now again, the video that I'm going to post with this is going to be better for you to understand this, because he's just better at me than explaining these things. Has nice pictures and things. But effectively, there's some sort of chemical reaction in here, some sort of physics reaction in here, that when I apply a small amount of current, it is going to allow the current from here to flow all the way through to the end. Okay, so a small amount of current to the base should effectively open this gate and allow the big current to flow through to the LED, to the resistor, and down to the ground. Okay, first step though is to, let's ignore this resistor and let's just get this set up first. Now the important thing is that it should not work. Yeah, well, it should work, but it shouldn't turn on the LED yet, okay? So our endpoint is to get there. So let's go back to our breadboard. Now I've already joined the power to here, so then I'm going to connect my transistor into there. Now notice transistor and resistor sound really similar, so transistor, resistor, transistor, resistor, transistor, resistor. Yeah, and it's not a transmitter either, as a lot of my kids get wrong. It's a transistor. So the left leg, again, the flat side facing forward. So see how we've got a round end with a dot, and then we've got a flat end. I'm going to have the flat end facing me, and I'm going to plug in to my breadboard. So I've got 3 different lines going into 3 different rows. If you connect it this way, it's no worky because you've just connected all the legs together. So let's do it as 3 different rows so that they have 3 different lines going into it. Now the other side is exactly the same as we made before. So I've got my resistor, the 220k, no, not 220, 220 ohms, sorry, 220k, and that's going to plug into the left leg. Maybe I can get it to fit into this. Here, as I've said before, this breadboard's been really troublesome. But anyway, it does work. Okay, and then the other leg is going to connect into the positive, the long leg of the LED. Now again, you can swap your resistor and your LED around. It doesn't matter which comes first and which comes second. The resistor will just reduce the current across the whole thingy. Okay, and then finally, I need to connect from my negative side. So see, this resistor is going in the positive side. The negative side of the LED has to connect back to the negative side of the breadboard. Dun, dun, dun. Squish, squish, come on, you can go in. There we go. Okay, and that one's going to go into the negative. The wire's a bit long, but it'll do. That's what we wanted to do. That's the main thing. There we go. Alrighty. So at present, I have positive flow into left leg currently being stopped by the transistor. However, later the right leg should allow the power to flow out into the resistor, into the LED long leg, and out of the LED short leg, and then back out into the negative side of the power. I hope you can see that. Okay. Now, theoretically, when I turn this on, nothing should happen. Yay! Exciting. Okay, so actually, what I'm going to do, I'm going to move my transistor one step forward, just so that I don't have too many wires crossing over each other for you guys to see. It's not going to make a difference to how things work, but again, just to show you, nothing is turning on, and that is because the middle leg of my transistor currently has no current. So I need to provide some current to that middle leg in order for it to turn on. And for that, I'm going to use a resistor. I'm sorry, again, I'm not sure how big this resistor is. Generally, I would suggest like a 10K, so 10,000 ohm resistors, are normally a reasonable size to choose for a system like this. Going into the middle of the base, I left most of my stuff at school again, so whoopsie, but I know this one is big enough to work. Now, if you put too much power into here, the issue you're going to have is you could possibly burn out the transistor, but also you don't want to be wasting power either as well, okay? So we want to, this is our like main flow of power, this is just sending a small signal into that power. So if I were to connect the middle line, I just check, not working. Okay, no. If I were to connect the middle line of the transistor, which I believe is called the base, into the negative line of my power on the other side, then again, nothing should happen because we're getting in no current from a negative. In this case, oh, success. Okay, so it's not working, that's good. But if I were to connect that same resistor to the positive line instead, and sorry, it's getting a bit dark here sunlight wise, but so hopefully it's going to be okay. But if I was to connect that into there, hopefully you can now see that when I turn on the power, so this gives a small amount of current to the middle, and that's allowing the current to flow across into the negative here. And that's the basics of how a transistor works. Now, probably like me, you're like, well, that doesn't seem that impressive. So when I first saw this, it's like, well, how does that help anything? That's just the same as having a button. In fact, were I to connect that with a button, it's gone crazy. What's going on here? Still getting some current from somewhere. Okay, were I to connect that to there, and then connect from there to the positive, so that it's only going to turn on if I give it a still very stiff. I'm going to get a better breadboard next time. So then if I connect it like this, so now if I press the button, it's going to allow power to flow to the middle of the transistor. So you're like, well, surely that's the same thing. Yeah, surely that's pretty much the same thing. Now, one thing to notice is just look at that. How cool is that? So it's actually just picking up on my body's electricity, and that's even enough to turn on the. That's even enough to kind of slightly turn on the transistor for a second. How cool is that? Anyway, so we need to talk about pull down resistors later. We can deal with that later on. So part of the problem is I don't have a wee outflow for it to deal with, but it works in general. And I'll talk to you about pull down resistors later. Okay, so we've got power flowing through here, and it's flowing into the middle thing that's opening it up and allowing it to flow. Why is that crucial? Well, not yet it isn't. But at the moment, when we... See? Stop picking up on stuff. Okay, so really what we should have is another resistor that's going to pull down from this bottom here to the negative, so that when there's a zero, it's like a real zero and not like a half zero, which is what's causing it issues at the moment. It's picking up on some kind of electricity from somewhere. But, and again, that just shows you how sensitive this middle line of the transistor is. Okay, so when I press it, that's going to do it. So, why? When we press 0, we get out a 0. When we press out 1, we get a 1. Now, hopefully some of you have just clicked. And that's because it's all to do with binary. So a 0 gives us a 0, and a 1 gives us a 1. And this is effectively what we call a buffer in logic circuits. It's a circuit which will basically hold the value. Now, it's not flip-flop, which we'll talk about another day, but it's passing on that value or maintaining that value in some way. Okay, now later on, the next class, we'll look at NOT gates, and you'll see maybe how we can start using transistors to give us even better